In this episode of complex number, we are going to deal the problems related to addition, subtraction, multiplication and division of complex numbers. The first problem of episode is Z1 equals to 1 upon 2 plus 3i, Z2 equals to 1 upon 3 plus 4i. Find Z1 plus Z2 equals to how much? Solution: Z1 plus Z2 equals to 1 upon 2 plus 3i plus 1 upon 3 plus 4i. Here I am going to use algebraic formula, that is 1 upon a plus 1 upon b equals to b plus a upon ab. Therefore, this is equals to 3 plus 4i plus 2 plus 3i upon 2 plus 3i and 3 plus 4i. This problem is involving all addition, division and multiplication. So first we will simplify the numerator part by adding it. So that is equals to 5 plus 7i. I request you, before watching this episode, you must watch the episode number 1 to 3. Then only you will understand this episode. Now denominator is 2 plus 3i and 3 plus 4i. Now we will multiply the denominator, that is a 6 plus 8i plus 9i plus 12i square, that is equals to 5 plus 7i upon 6 plus i is common, 8 plus 9 plus 12 into minus 1. I square equals to minus 1, that is equals to 5 plus 7i upon 6 plus 17i minus 12, that is equals to 5 plus 7i upon 6 minus 12 plus 17i equals to 5 plus 7i upon minus 6 plus 17i. So now Z1 plus Z2 equals to plus 5 plus 7i upon minus 6 plus 17i. Now we are rationalizing the denominator, that is multiplying and dividing by the conjugate of the denominator, minus 6 minus 17i upon minus 6 minus 17i, multiplying and dividing by conjugate of denominator. Therefore we get now 5 plus 7i and minus 6 minus 17i upon minus 6 plus 17i and minus 6 minus 17i. So this is equals to, now we can multiply the part of numerator as well as denominator. In denominator it is a plus b and a minus b equals to a square minus b square, and numerator part is a plain multiplication. So we will simplify both now, numerator and denominator. Now opening the brackets, so we get minus 30 minus 85i minus 42i minus 119i square upon minus 6 square minus 17i whole square. This is equals to minus 30 minus 85i minus 42i, that is equals to minus 30 minus I taken common, 85 plus 42 minus 119, I square equals to minus 1 upon 36 minus 289 I square. Now 85 and 42, that is equals to 127. So minus 30 minus 127i plus 119 upon 36 minus 289 multiplied by minus 1, that is equals to minus 30 plus 119 minus 127i upon 36 plus 289, which is equals to 89 minus 127i upon 325. Therefore, Z1 plus Z2 can be written as 89 upon 325 minus 127 upon 325i, which can also be written as 1 upon 325, 89 minus 127i. This is the way we can find out the addition of two complex numbers. Thus, in a single problem of complex number, addition, subtraction, division, multiplication, all may together. It is not like that ki only addition will come or only subtraction will come. Okay, as you grow in complex number, all need to be involved. Example, in this problem, Z1 is given, Z2 is given. We need to find out Z1 plus Z2 upon Z1 bar minus Z2 bar. So in this problem, addition is also involved and subtraction also involved and division also involved. Of course, multiplication will also be involved to simplify the given problem. So first of all, Z1 equals to 2 plus 3i. Therefore, Z1 bar equals to 2 minus 3i. And Z2 equals to 1 plus 2i. Therefore, Z2 bar equals to 1 minus 2i. After that, we have to find out Z1 plus Z2 upon Z1 bar minus Z2 bar. So Z1 is nothing but 2 plus 3i plus 1 plus 2i upon Z1 bar, that is nothing but 2 minus 3i, and here is a minus is there, Z2 bar 1 minus 2i, that is equals to 2 plus 1 and I common 3 plus 2 upon 2 minus 3i minus 1 plus 2i, that is equals to 3 plus 5i, and in the denominator 2 minus 1 plus I common minus 3 plus 2, that is equals to 3 plus 5i upon 1 minus I. So we got here Z1 plus Z2 upon Z1 bar minus Z2 bar equals to 3 plus 5i upon 1 minus I. Now we need to simplify this. For that we have to rationalize the denominator. So that is multiplying and dividing by 1 plus I upon 1 plus I, that is equals to 3 plus 5i into 1 plus I upon 1 square minus I square. So now opening the bracket, so we get here 3 plus 3i plus 5i plus 5i square upon 1 minus 1. So that is equals to 3 plus 8i minus 5 upon 1 plus 1 equals to minus 2 plus 8i upon 2. If common is possible, you can take the common in the numerator. So I am taking 2 common in numerator. Minus 1 plus 4i upon 2. 2 and 2 get cancelled. Therefore, we have taken common so that they cancel each other. Therefore, we got here minus 1 plus 4i. Therefore, z1 plus z2 upon z1 bar minus z2 bar equals to minus 1 plus 4i. This way, a given complex number may involve addition, subtraction, multiplication, division. All when you perform, you will get the one result. Next example, if 5 upon 6 plus 4i equals to x plus iy, find x and y. Solution: 5 upon 6 plus 4i equals to x plus iy. Now we are rationalizing LHS here, that is multiplying and dividing by 6 minus 4i upon 6 minus 4i equals to x plus iy, that is equals to 5 into 6 minus 4i upon 6 square minus 4i whole square equals to x plus iy, that is equals to 30 minus 20i upon 36 plus 16. So 30 minus 20i upon 52 equals to x plus iy. Since we have to find x and y value, so keeping them in LHS, and 30 minus 20i, 30 upon 52 and 20 upon 52. Comparing real parts. Comparing real parts. Therefore, x equals to 30 upon 52. Comparing imaginary parts implies y equals to minus 20 upon 52. Here first answer was x upon x equals to 30 upon 52. You can cancel by 2. 2 ones are 50 and 2 twos are, so that was the 15 upon 26. And here also you can cancel here. 2 tens are, 2 twos are, 6 are, so minus 10 upon 26. Therefore, further cancellation possible here. 2 5s are and 13. Therefore, x equals to 15 upon 26 and y equals to minus 5 upon 13. This is solution set. If z equals to I plus I square plus I cube I raised to 4 plus I raised to 6 plus I raised to 8 equals to x plus iy, then find x and y. Before watching this video, you must watch my episode number 3 for understanding this problem. Now what we are given? We are given z equals to I plus I square plus I cube plus I raised to 4 plus I raised to 6 and I raised to 8 equals to x plus iy. We need to find x and y, therefore keep them left side. Then I is I and I square is nothing but minus 1 and I cube nothing but I square into I raised to 4 nothing but I square whole square, and I raised to 6 is nothing but I square whole raised to cube, and I raised to 8 nothing but I square whole raised to 4. That is equals to I minus 1 plus I square is minus 1 into I plus minus 1 whole square minus 1 whole cube plus minus 1 raised to 4. That is equals to I minus 1 minus I plus 1 minus 1 plus 1 x plus iy. So x plus iy equals to this I and minus I get cancelled, minus 1 plus 1 get cancelled, minus 1 plus 1 get cancelled, so 0 plus 0 I. Nothing is left at RHS, so writing 0 plus 0 I implies x equals to 0 and y equals to 0. That is comparing real part. So real part left side is x, so x equals to 0. Comparing imaginary part, therefore y equals to 0. Therefore final answer is x equals to 0, y equals to 0. This is a solution set. Next example, write 1 upon 2 plus I plus 1 upon 1 plus I plus 1 upon 4 plus I in x plus iy form. Solution: 1 upon 2 plus I, 1 upon 1 plus I, 1 upon 4 plus I. Before solving this problem, here I would like to give you one algebraic technique. Suppose I am having 3 fractional part, 1 upon A, 1 upon B plus 1 upon C. Then how to add them? So the idea is that there are the 3 numbers in denominator. So first step is A into B into C. That is the step number 1. In the step number 2, ask yourself, in the first fraction, what is there in the denominator? In the first fraction, the denominator is A. So for the first part, we are having A, B, C. In the first part of the denominator, there is A. So write A here. A get cancelled. Write down B, C. Then ask yourself, what is there in the denominator of the second fraction? B. So again write down A, B, C and divide by B, cut down, equals to AC. So write down here AC. So in the third part, in the third fractional part, there is a denominator C. So write down ABC and C get cancelled. So plus AB and divided by ABC. So the simple way it can be remembered, what is there in the first part of the denominator? A. So don't write A, write other the 2 parts, that is a B and C. In the second fraction, denominator is B, so don't write B, write down the other 2 parts, that is A and C. And in the third denominator, there is a C, so don't write C but write A and B. So this is the way we can do the addition of 3 fractions given in this form. So here 1 upon 2 plus I, 1 upon 1 plus I, 1 upon 4 plus I. So first of all, write all the 3 in the denominator. That is a 2 plus I and 1 plus I and 4 plus I. Then for the first fraction, don't write 2 plus I, write down the remaining 2 part, that is 1 plus I and the 4 plus I. For the second fraction, out of the 3 in the denominator, there are 3 parts are there, 2 plus I, 1 plus I and the 4 plus I. So in denominator there are the 3 brackets. So what to write, what to not write? You have to not write 1 plus I for the second part. So you can write down 2 plus I and 4 plus I. And for the third fraction, don't write 4 plus I, but you write down 2 plus I and 1 plus I. Now we'll multiply every 2 brackets and write down the results. So that is a 4 plus I plus 4I plus I square plus 8 plus 2I plus 4I plus I square plus 2 plus 2i plus I square. In the denominator, we first multiply the two bracket, keep the third bracket as it is. So 2 plus 2i plus I square. I multiplied the first two bracket and keeping the third bracket as it is. Now, wherever I square is there, we shall be writing minus 1 there. That means I square shall be replaced by minus 1. And wherever addition of I possible, will add them, like I plus 4i, that is equals to 5i. And wherever I square is there, write down minus 1. So 8, 2i plus 4i, that is 6i. And I square equals to minus 1 plus 2. 2i plus I, that is equals to 3i, and I square equals to minus 1. In denominator also we do the same thing. 2 plus 3i and I square equals to minus 1, and writing the third bracket as it is. Now, bringing all numbers together, here is a 4 minus 1 plus 8 minus 1 plus 2 minus 1, and taking I common, 5 plus 6 plus 3. In the denominator, 2 minus 1 is 1, 1 plus 3i multiply to 4 plus I. So here the minus 1 plus 2 get cancelled, and so we got here the 4 plus 8 minus 1 I, and here is a 14. In denominator we multiply the bracket, open both the bracket now, 4 plus I plus 12i and plus 3i square. So that is equals to 11 plus 14i upon here 4 plus 13i minus 3 equals to 11 plus 14i upon 1 plus 13i. X plus iy equals to 11 plus 14i divided by 1 plus 13i. Now it is in the not a pure complex number because upon is there. So what you can do, you can rationalizing the denominator, 1 minus 13i upon multiplying and dividing by conjugate. So that is 11 plus 14i multiply to 1 minus 13i divided by 1 square minus 13i whole square, that is equals to 11 minus 143i plus 14i minus 14 and 13, 182 I square upon 1 plus 13. Therefore x plus iy equals to 11. I taken common here, that is equals to 11 plus 182 plus I minus 129 upon 14. This is x plus iy. So x plus iy equals to 182, 11, 193 minus 129i upon 14. So x plus iy equals to 193 upon 14 minus 129 upon 14i. So given complex number we could express in form of x plus iy, where x equals to 193 upon 14 and y equals to minus 129 upon 14. So, in a single problem of complex number, we need to apply addition, subtraction, multiplication and division of complex numbers. Hope you are enjoying mathematics. I wish to inform you that even I got the playlist on trigonometry and derivatives. Please visit and please give me your feedback. In the next episode, I shall be talking about modulus of a complex number and amplitude of a complex number. Till then, wish you good luck, all the best. Meet you again soon with modulus of complex number and amplitude of a complex number. Wish you good luck, all the best.